Yes. Control Shift to Tick. Yes, Pyspark. So today I'll be discussing about Spark SQL. That's introduction to Spark SQL. Spark SQL. Spark SQL is used, right, to process Spark data objects. Spark data objects using SQL statements. Using SQL statements. Spark SQL is used to process Spark data objects using SQL statements. Spark data objects are called as ODDs. Spark data objects are called as ODDs. Spark data objects are called as ODDs. On top of ODDs, data frames, right? On top of ODDs, data frames are introduced. Spark SQL is used to process Spark data objects using SQL statements. Spark data objects are called as ODDs. On top of ODDs, data frames are introduced. ODDs need to be converted as data frames, and these data frames should be registered as tables. RTDs need to be converted as data frames, and this data frame should be registered as tables. To execute SQL statements. Data frames are equivalent, right? Equivalent to temporary SQL, temporary tables of SQL. Spark SQL, right? Spark SQL. MySQL standard, standard SQL, right? Standard SQL. Spark core provides context to object. Spark core provides Spark context to object. Spark core provides Spark context to object. Spark SQL, right? Spark SQL provides SQL context. SQL context to perform SQL operations and RTD operations. Spark SQL as a subcomponent called Spark SQL as a subcomponent called Spark HQL. Spark HQL, right? Yes. Which provides Spark SQL as a subcomponent called Spark HQL, which provides a context to object called Hive context object. Spark SQL as a subcomponent called Spark H, which provides a context object called Hive context object. Using this, Spark can be integrated. Spark can be integrated. Spark can be integrated with Hive. So that from Spark itself, we can perform HQL operations. So from Spark itself, we can perform HQL operations with in-memory computing features. Operations on an RTD, for example, operations on a RTD. Spark context. What is that? Spark context. Operations on a data frame. Operations on Hive tables. So operations on RTD, Spark context. Operations on a data frame, SQL context. Operations on Hive tables, right? Operations on Hive tables, Hive context. Hmm. Observe
So
this.
what is that context? Spark context, SQL context.
See, every time in RTD's creation, SC dot parallelize. What is that SC? Spark context. SC dot text file. Whenever you're loading a file from HDFS, SC dot text file. What is that SC? Spark context. SC dot parallelize. Same way for data frames like Spark context, we have got SQL context we need to use. And for Hive, we need to use Hive context objects. Yeah. Data frame, right? Data frame is a collection of row objects. It's a collection of row objects. Each row object, again, each row object represents a record. Data frame is a collection of row objects. Data frame is a collection of row objects. Each row object represents a record. Data frame provides operations to SQL. which is not present in RDD. Data frame provides operations to SQL which is not present in RTD. Data frame is a collection of row objects. Each row object represents a record. Data, okay. Creating data frames. Creating data frames.
And directly we cannot query RDDs, right?
Yeah, data frame up. DF provides that operations to SQL, but which we were not, up to now we discussed RTDs, right? Where we didn't see any kind of querying there. In data frames, we can see that kind of queries, SQL queries you can apply. Data frame can be created in 4 ways. Data frame can be created in 4 ways, right? First thing, from RTDs. From RTDs you can create. From local objects. Python objects. From RTDs. From local objects, Python objects. From RTDs, from local objects, Python objects. From results of queries. From RTDs, from local objects, Python objects, from results of queries. From external data sources, So data frame can be created in 4 ways. From RTDs you can create, from local objects, Python objects, from results of SQL queries, from external data sources. Creating data frames from RTDs. First one. For converting local object or RTD. For converting local object or RTD into data frame, we use the following method. For converting local object or RTD into data frame, we use the following method. Spark.create data frame. Spark.create data frame. List or RTD. Schema. First parameter. Either list or RTD. First parameter either list or RTD. Either list or RTD. Second parameter column names. We can create a data frame. We can create data frame using first one, Spark session. Using Spark session. We can create data frame using Spark session or SQL context. For example, Spark.create data frame. Understand this? We can create data frame using Spark session, SQL context. Creating data frames from RTDs, RTD.2df data frame gets created. For converting local object or RTD, this list or RTD, you want to convert to data frame, typecasting just Spark.create data frame, right? Data frame gets created from a list or RTD and schema. First parameter is list or RTD, second parameter is column names. We can create a data frame using Spark session. Spark.create data frame from RTD data frame.
Sir, here in Spark, we don't have a database concept, right? Like we have in Oracle, tables are created under a particular schema in a database.
What is that?
In Spark, we don't have a database concept, right?
Database? No.
So when we create this RDDs or data frames,
Hmm.
they are stored as a file, right?
Hmm.
Not under any particular database.
No. From a database also, you can take a database table and create a data frame from it. From a CSV file, you can create a data frame. From a JSON file, you can create a data frame. From a database table, you can create a data frame. Data frame means structured rows and columns like Excel format.
And where is it stored? It is stored in the HDFS.
So it's a Spark object, right? It will be stored in HDFS.
Okay. Okay.
Here, what is Spark here? SQL context dot frame or DD. SQL context dot create a data frame of OTD using SQL context. Okay, we can create data frame using Spark session in SQL context. SQL context dot create data frame, right? Yes. So you providing schema, right? Different ways of providing schemas, right? It's just here schema. Four different ways of providing schema. Four different ways of providing schema. Four different ways of providing schema. First one, while creating data frame. Providing schema. Second, using dictionary. Using dictionary. Using row object. Using row object. Using struct. Using struct type. While creating data frame, provide schema using dictionary, using row object, using struct type. First one, example one, right? Yes. Creating data frames. Creating data frames from lists. How to create data frame from lists, the local objects. Creating data frames from local objects, lists. For example, x equal to a list, name Miller, age 25. Next, Blake, age 30. Miller 25, Blake age is 30. Data frame equal to spark dot create a data frame, create data frame of x. Spark dot create a data frame of x. That's it. A list is there, a list of two values, two elements. Spark session dot create a data frame of x. That's it. Df dot show. Df dot show. Yes. Df dot show. Yes.
So I have one question. The exact same syntax will be working in Jupyter notebooks also?
1 second.
So here we haven't given the column name.
Yeah.
So
Yes. 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 Okay. So here, 1 second. In this Spark, so if you observe this in the starting, whenever you say Spark session available as Spark session available as Spark. Directly I can use Spark now. Spark dot create. Spark dot create. But in Jupyter Notebook, that Spark session won't be available. So in the last class I discussed, right? In the last class I discussed one example, right, of data frame. You can see Spark. So in in this Jupyter Notebook, just first you need to create this Spark session like this one line. So this is the import statement for Spark session. This is the statement to create a Spark session object. Remaining everything same. These 4 lines what we have typed here, but in Jupyter Notebook, this is one import statement and this is Spark session. It is not available. Spark session won't be available in
So
Jupyter.
once we do this, we'll get the Spark UI, right? I think it is coming up. We'll get the
Yes,
Spark UI, and then I think we can then use these statements. Okay. Okay.
yes, it displays this next. That's the only thing. Here it's clearly saying, right? Here, if you open this as clearly it is saying Spark session available as Spark. Directly you can use, no need to create again, right? Yeah, now here, yes, someone was saying that there are no column names here. Okay, not this. The other example. There is no column names here. They're getting underscore 1, underscore 2, right? So example 2 for that. Creating data frame with the schema. Creating data frame with schema.
So when you say schema, it means the column's name, right?
Yes.
Okay.
Then observe here. Miller, Blake, one more like James. Miller, Blake, and James. Now, just say df dot data frame spark dot create data frame x, but call see just comma schema. Schema means column names. What is that column names? Name, comma age. That's it. Previously, if you are not given this, you will get _1 and _2. Yes. df dot show. df dot show, right? Name, comma name, age.
Can you show the previous code once? Okay.
Data frame of x just families, but here x comma name age.
Sir, here schema means column name.
Schema means
What is the meaning
Yeah.
of schema here?
or column names, right?
Data frame is like a table, na?
Data frame is like is just like a table you will get in a structured format, rows and columns. Okay.
Sir, one question here, like, so suppose we opened one particular session and then created a data frame. So that particular session data frame will be available for another session.
No.
Okay.
df dot count data frame dot no, it won't be available every time we
Because
need.
you said temp tables, it is like a temp table. So temp table, when we create a temp table, then it is available on that schema until we drop it.
So until the session is closed, then it will be temp tables will be available. You can perform query. Once it is closed, no.
Okay.
To count the number of variables, to count the number of rows, to count the number of rows in a data frame. To count the number of rows in a data frame. Okay, to count the number of rows in a data frame, right? df dot count is what? Right, 3. Hmm. Print schema S capital, right? Print schema. For example, once data frame is created, data frame dot print schema. Data frame dot print schema. Name and age.
Here we are not providing any length, right? So automatically it will, whatever the length, maximum length, it will, based on that, it will capture that column.
You're talking about which one?
I mean, name, we did not define the length. It's just giving the data type, right?
Yes.
Like where character, whether it is 50 characters or 100 characters, and not defined it, right?
Yes.
So automatically, whatever may be the value, it will be taken under the name column, right? Maximum value. Okay.
Sir,
Sorry,
it will tell the data type na print schema.
Print schema means prints that column name and the data type.
Sir, what if df dot columns will do?
Prints all the column names.
So schema and
With the data,
columns.
with the data type, it is going to print. Okay. Now, next step. Using dictionary. Using a dictionary. Providing schema. Using dictionary, providing a schema. And creating a data frame. Okay. X equal to square bracket. Name Ajay. Name Ajay, age 25. Name Rahul, age 30. Spark dot create a data frame of X. Df dot show. Name Ajay, age 25. Name Rahul, age 30. And city Pune. In the first one, city is not there.
This is a list of dictionary, right?
List of dictionaries. Data frame I need to create a spark dot create a data frame. Create a data frame, right? Yes. Df dot show. Null value you got. For the first one, city is not available. You got null value.
Vijay, suppose if I want only the name and age, I don't want the city, then in that scenario, we just need to define the schema, column
Yes.
name.
No, we have got selected. Just like there, we are also got select here. You want to select only particular things. I'll discuss it.
Okay.
How to select only selected columns, filtering, groupings, all that.
All right.
Next. Creating a data frame. Creating a data frame from a RDD. Spark dot create data frame of OTD. Adding schema to a RTD. How to provide the column name? How could you provide the column name names? And just observe this. I'm creating df2. df2 equal to spark dot create data frame D capital F capital. Spark dot create data frame from RTD.
And if we give the sc dot parallelize, it will convert into the RDD, right?
What is it? Some query was asked.
Sc dot parallelize is used to create just RDD, right? Convert that list into the RDD, right?
Yes. And again from the RTD to data. See if this list converted to RTD, again the RTD converted to data frame.
Okay.
And in this, I'm
So
providing
finally,
the
once the RDD is converted into a data frame, then we can query, right?
directly you cannot query. Again, you need to create temporary tables on that you can perform query.
Oh, okay, okay.
You will create a temporary table with some name. On that name, you can perform query. Next, this
Okay.
is creating a data frame using row object. Creating a Miller 25. Ajay 30. Now creating a data frame using row object. One second.
So I don't hear anything. Hello, am I audible?
Yes, you're audible, I think.
Miller 25, Ajay 30, Blake 45. RTD equal to SC dot parallelize. Now, what is that? What is that? How to create a data frame using row object? Now, providing a schema to a RTD. Now, providing schema to a RTD. Providing schema to a RTD. For example, customer row object I'm creating row of okay. Before this, I need to give before I want to use a row, right? I need to use an import statement for row. From Pyspark.sql. From Pyspark.sql. Import row. From Pyspark.sql. Import row.
So what is a row actually?
Yeah. Row object we say. So first import this row and creating a row object.
No, I mean, what is a raw object actually? For what
One
we are
second.
using?
1 second. I'm using this. See, just like list object in list object here, we got some row object also. So just observe this. First, we need to import it from Pyspark.sql. Import row. We need to in this it is available. In this package, it is available. How to provide a data frame? How to create a data frame using row object? See now, from Pyspark.sql, import row. A row, ROW. Row of what is that? Name. I'm providing schema. Name, comma, age. What is it? For example, custom. I'm giving any name. Give any name. Customer equal to a row. Row of name, comma, age. Yes. So what is the type of customer? What is the type of customer? Yes. What is the type of customer? Row type. What is the type of customer means as you are assigning a row to this variable. So the type is going to be row type. So now, yes, RTD is there at RTD dot map. RTD is output map lambda lambda. Take one variable p. Just say customer all custom lambda p 1 by 1 element. 1 by 1 element all like a customer fields. Customer star p. Store it as a custom object. So RTD.map. So CUST is also what? An RTD is going to get Spark object. Spark object is going to get created. So if you see all I want row objects, I want to create row objects. If you say customer.collect, if you see right RTD.collect, you can see all the row objects now. Row. Name Miller, age 25. Row name Ajay, age 30. Right, all that. So just what I did here, right? Now you got row object. Now after creating row object, this row object, okay. RTD, cust is what? An RTD of row objects.
So can you explain the lambda line actually? Lambda RDD dot name.
Lambda, okay. P means each element. Each element of this RTD, each element of this RTD means each tuple.
Yeah.
Each element means each tuple, right? Each tuple means what? This one, row type. Each tuple, customer of, right? Yes, customer means this one. Customer of,
Why do you have given the star dot p here?
see all
Oh,
the threads. P means what? Each element. All,
yeah, each tuple.
right? Means,
Mhm.
okay. So here star P means all I want like customer object type. All I want like customer object type. So what happens? Customer RTD with all are will be of row type. All are going to be of row type. So here lambda P, each tuple I want like customer row object type. What object? Row object type. So customer. So what is customer? Row type. So like customer of all this star P.
So first element always will be a name, and second element of the tuple will be age, right?
Star P means what?
According.
There's a concept called arbitrary arguments in Python. Star P indicates the arbitrary arguments means any values. You can have one value, two values.
So
three
it is
values.
like, sir, you are defining P there, right?
Hmm.
P object.
Each one is an arbitrary type. So each one will be of customer object, row object type. So just what is there? See, just row of name comma age, row of name age, row of name age. But this arbitrary argument we are taking, okay, row of name age. See here, row type I want all that customer of row type. Each P means each tuple I want like row type. This way. P is what? Each tuple I want like row type in this way.
So
So
we
row
can
of-
have any other value other than P, right? Not just P, we can put something else also.
Yeah, you can keep, and here star A you should say.
It's like alias kind of, right?
Yes.
Okay.
Now
And so these like 3 step, it is compulsory to perform, right? First is like putting that line Pyspark SQL import, and then second the customer that you have put row name and age.
this one I said say we'll go up. While creating data, which one? Different ways of providing schema using row object, using dictionary, using struct type while creating data. So most of the time this will be the better one, right? While creating data frame, providing schema or using dictionary. But these two will be little complex. The first two will be very simple, what we have discussed. But row
Okay.
objects using struct type will be little complex. So you can
So
go.
currently you are explaining third point, right?
Yes, 4 different ways of providing schema. You can use any of this, right? But the first two looks very simple, right? But row object again, first you need to create row type, then again each type to be of row type, and that's creating data frame. This using struct type also it will be little simple only, but as compared to the first two, right?
Sir, providing the schema, it means like a column name, you mean? A schema, it means?
Yes,
Column name only.
name and data type.
Name and data type. Okay, fine. So here also the first value of the tuples is taking like a name, and second value of the tuple is taking like age. Can we shuffle it like first value as age or something? How do we do that for
Image.
this?
Column names. As how we are providing, it is taking the same manner, name age.
Okay.
You want to give
And
age comma name, you can provide.
Okay. Why do we need like row type here? Is it mandatory to have a row type?
I'm saying even from see generally in the coming example we will say whenever you see row type directly you can create a what is that data frame from the row types.
No, what is the need of row tab if we have already other tab, dictionary tabs? Now we are creating the data frame, right? So is it necessary, mandatory to create convert in the row tab and then create the data frame? Is there any requirement?
Here
such
also you are
requirement?
giving schema right using row of name comma age. Here also you are providing schema using row of name comma age you are saying.
No, I was telling sir, actually, do we really require the row type? And means like we have already create the data frame some other two way actually, right?
With
Where
different
we can use the row tab
see
actually.
different ways of creating schema I'm saying. Different ways means this is also one way of providing schema. Previously I said
Which use case I can use the row actually? Is it really required the row type? That's my question actually. Any use case whether we have to be use row type only.
row type this is also one way of creating providing schema. 4 types are there. Which one you prefer? You will use that. 4 ways of providing schema is there. Which one you can just go with that? This is row using row object is one of the way, right? Providing schema to a RTD.
Okay, so there's no any specific requirement there. We have to go only the row type, right?
No, you can go with the previously what we discussed in that way also. But using row also we can.
And sir, just a moment. Why do we need a data frame actually?
Hmm.
Why do we need a data frame?
Data frame is just like a structure, right? Structuredness, rows and
Mhm.
columns type. If you want a particular row, particular column, only specific row, specific column, and we perform
Mhm.
any data frame APIs are there. We perform it. So you will get a kind of structuredness, right? Where we can perform some kind of querying also. Next, I'll be showing you how to perform like pure SQL queries using this data frame.
Okay, so to make in a structure format, the data frame is needed in it, right?
Data frame is a structure like a table, right? Which has got rows
Yeah.
and columns, which are making the data structured and storing in a tabular form. Later, the data frames you can also performing querying, right? By using temp tables, by creating temp tables.
Okay. Okay, fine. Thank you.
Now this is also another way, right, of providing schema. Different ways of providing schema means here providing schema means you won't see the column names. So I'm providing these column names. So this is there, right? This is the first example what we have discussed today. Same thing. You won't get the column names. To provide the column names, this is the way. Always use row object. Schema using the structure type. Using structure type, right? Yes. Providing schema using structure type. Now this is also little complex, right? Providing schema using this structure type. Dot types. Import star. From Pyspark.sql.types import star. import star, right? Okay. First schema, square bracket. Okay, schema I want like structure type. S capital, yes, structure type. Square bracket, schema equal to structure type of square bracket.
What is the first line? You have import statement, you meant?
Import statement, right? Pyspark SQL types import.
Okay.
Okay. Types means we use like string type, integer type. There's some types we'll be using now. So structure type is,
Data types.
so for this structure type I am using. Structure field I am using. First one, name. Name what type? String type. string. S capital, T capital, string type. True. How many columns you want? This same, this you need to repeat. Again, say one more struct field. Again, one more struct field. What is that? Name you want? Age. What type? Integer type. I capital. Integer type. What type? That is true. TRUE. See here, yes, this square bracket opened here, square bracket closed here. How many struct fields? Two struct fields, name and age. What type they are? First one string type, integer type. df4 spark dot create data frame. Spark dot create a data frame of RDD, comma schema. In the previous, we have got RTD, right? Using row type, you are providing schema. Using structure type, you are providing to this RTD. This RTD is there, right? For that, I'm providing using the structure type and using row type. df4 dot show.
So what is this true coming for?
See, 1 second. Nullable equal to true. Generally in SQL also, right? For example, Control Shift T.
This databases and all, this is like Hive or you logged into MySQL?
MySQL.
Okay.
Describe EMP1. Sorry. Describe EMP1. See, what is this? Field name, column name, EID, type integer. Okay. So here, what is this? Okay. Field type null. Yes, right? EID, no. So the same way, this one nullable equal to true means yes. Here in the same case, in this example also, nullable is true.
Here, can you show me how you connected to MySQL, please?
Here first column says null no, but default is null. What is then?
See, here EID compulsory, you should have some name, right? EID compulsory, you have some name. But default value null, if you're not providing, right? Null values for this.
But primary key cannot be null, right?
Yes. That's why it is said null, no. But remaining all, yes.
But in default, it should not be there, right? In default, null also it is present in the first column.
Just it provides that, but compulsory we need to provide. But then generally, without this EID, it won't consider, right?
Okay.
Compulsory need to provide. So how to connect with this means MySQL -u, username is Hadoop -p, say enter. Hadoop HADOOP is the password. MySQL, it's going to get opened. Show databases means to show the available database. You can create your own database and you can create tables in that. For example, okay, this is structure type, this first, okay, different ways of providing schema, the 4 ways. This first 2 will be simpler. This next 2 will be little complex, right? So now changing schema or column names.
Vijay, so there are 4 ways, right? Like if I use struct type, will there be any performance issues, or whatever we use, that will be the same. There will be no impact.
No,
Or is there any better way? This if you use this approach, right, that will be the best way for defining the column names or whatever.
see, row type, okay, structure type we never use in our coding type, right? But row type we'll be using. I'll show you some examples in the coming sessions, right? Structure type we never prefer at all. But most of the time, the first 2 will be preferring. Row type also will be preferring. I'll show some examples in that. Row type, whenever you take some employees data, customer data, first you will take off customer object, row object types. And once the row object is created, you can create a data frame from it.
Okay.
So can you explain no, the struct type a little bit? No. One second, I really did not get properly.
See here,
This one.
schema. What type? Struct type. Here it is open, here it is closed. In the struct type, you provide how many struct fields? 2 struct fields, name and age. Name should be what type? String type. Age should be what type? Integer type. Null, it's true and true.
Suppose if it's primary key, then what could be the null label? It's a false, true? No, false, right?
There is no like that kind of primary constants here in this.
Okay.
In database, you see here, you won't see those. Changing schema, changing schema or column names. For example, name is there, right? Name is there, I want EMP name, employee name. Age is there, I want EMP age. I want to change the column names. Change schema or the column names, right? Yes. dfi equal to yes. Spark dot create data frame. Spark dot create data frame from this RTD. Schema, you can provide the schema now. Ename, what type? String type. Ename, employee age, EMP age. What type? Int type. EMP name, string EMP name, int type. Directly you can do like this, no need of that spark.create data frame from RTD and provide the schema in this way. dfi.show. Now here dfi is a data frame. Converting to RTD means dot RTD. Data frame dot RTD. Okay, now it is an RTD, right? Dot I want to know the get num partitions.
So in the above examples, you have changed the name of the schema, right?
Yes.
Not to be data type. Then is it mandatory to give the data type in the above? Like EMP name.
EMP name, yes. No, not compulsory, but I'm specifying that EMP in this way also you can do EMP name string type EMP name. Later, if you say print schema, you will see employee age as int, employee name as string.
Yeah.
So while providing schema, I want to age as integer type you are giving here. And string type, which one name? Providing schema like this. Schema means what? Column name and data types, what you want to provide.
Okay.
RTD data frame dot convert to RTD got get num partitions. Yes. There is a typo. Get num NUM, right? Got num partitions, one partitions. Okay, fine. I'll forward you all this once you get try it, right? Introduction to data frames, how to create data frames, different ways of providing schema. Yes. Tomorrow we'll see some operations related to it and some different data frame APIs. How to select a particular column, filtering, grouping, joins, various other operations.
So what is this last one? Get num partitions?
You know, in RTD we have discussed that RTD got in RTD divided into how many partitions? That those partitions, only one partition it is. To know the number of partitions.
Okay.
So this
Okay.
partition based on which column it is showing one?
But the partitioning means not that partitioning. If
Okay.
the file is divided into how many partitions? Only one partition. Means data object has got how many partitions? Only one partitions. RTD dot get num partitions. In the previously we have discussed it in the initial classes. To know the number of partitions in a RTD has got. Right?
If I want to increase the partition number, how do I do that?
Increasing can't be done. If you want to decrease, you can.
Okay, how do
If you want to, If you want to increase it using parallelize, you can increase.
Okay, okay, yeah. The second parameter, yeah.
Yeah, your second parameter you can, we have discussed those things, how to increase that. And while loading a file, you can increase, I said,
Yeah, okay.
HDFS file.
So what the actually benefit of increasing the partitions, right? Like it's a time less time consuming, right? I mean,
Load across multiple systems, parallel processing increasing, right? Speed increases.
the speed will
Mainly
increase.
the
Okay.
performance, right? Performance, it will improve
So
the
if
performance.
work done by single person, work done by two persons. If two partitions, two systems. Okay. So in Spark, you can control that parallel processing, right? But in Hadoop, it cannot be controlled. Here we can control it. So we'll take some more examples in the tomorrow's class. More discussion on this data frame, right? Data frame APIs. Yes. I'll forward
So
it.
I think we have still dots in the partitions part, sir. Can we have one special some 10 to 15 minutes in partitions? Like we have a 10 system, then how could I partitions? How could I how much partition we can do and what is the recommendations?
While in the theory classes, I discussed about all this, right? Partitions, how the RTDs are computed.
But that was in theoretical only. But can we have a related to the
What you want to
practical?
know more on these partitions?
Like as a working, if I as a developer, I have a 10 system and I wanted to be, I don't know how many partitions I can do so that our,
How many partitions
process
you
will.
want to do? How many partitions do you want? It depends. If you want to give two partitions, three partitions while loading data.
How
Why?
could I understand we have to give it 3 partitions only? Maybe we can give it 10% partition. What could be the recommendations one actually?
First, you
That's so much.
know how many partitions it has. How many partitions it has? First, you know it. If you want to increase or decrease, we already discussed about how to increase partitions, how to decrease the partitions using coalesce function. You can decrease coalesce. Can you remember coalesce?
Yeah, I remember everything.
Mm.
The question is that only that not able to understand really that how could I handle with the partition actually? What is recommendable to do that now? Which partition? Whether we have to increase or decrease? How based on that? How could we decide actually?
So if you have got many systems, you have got many systems, right? You can go with more number of partitions for getting more parallelism, right?
Okay, so we have
So
if we have a many system, it's recommendable to go with many more partitions, right?
more partitions you can go. It means your data object is going to get distributed across multiple systems. Instead of storing in one or two systems, you can increase more partitions distributed across more systems, more RAMs that are processed parallelly, right?
Okay, so if we have a less system, then accordingly we can go with the less partitions, right?
Yes.
Just an example, if I have a two system, is it recommendable to go for the two partitions only or more than two only?
If you can go with 10 partitions also in the two systems. But 5 partitions in this first system, 5 will be in the second. But only that is partitions increasing. If you got more systems, more parallelism you get. But here in this first, if you have got storing more partitions in the single system, some jobs will be in the waiting state.
Okay, okay. So that is why, see, this is only I wanted to understand, sir. Yeah. Like, this partitions, how could I decide based on that, systems? So waiting state should also not be happen and partitions should be also depends on the number of system, right? That we have to
So
both we
only
have to
one thing,
adjust.
you got more systems, more RAMs available, then you can go with more partitions. Depends how many to 30 how many partitions you want to divide, you can divide it. Bigger data object into any number
Yeah.
of partitions you can create. Already how many partitions it has? 30 partitions are there. You have got 40 systems. I want to make it 40. Give 40. In 40 systems it will be stored, it will be computed. processed. This one.
Okay, so we need to see that number of the RAM capacity also on the system.
Yes, yes.
Okay, yeah, got it here. Thank you, sir.
Okay, we'll continue tomorrow, right? Fine. I'll forward you the notes
Yeah.
just to go through it.